Hello, my name is Dmitry Orlov, Dmitry Orlov, some people are listening, and today I'm going to give you a lecture about introduction to the world of GDV electrography. Let's start. So let's start our lecture. Well, we will have to start from the history. Well, because you know that if you are not learning history, you are doomed to repeated mistakes. So you have to know the history. And one of the main objectives here is that you will have to answer the questions of your potential clients or your potential users or just relatives and friends who will ask you what kind of education has you got, and if you have got a degree in bioelectrography, well, you should be able to explain that this is not something absolutely brand new that has just appeared on this planet. No, it has a pretty long history. And the history of GeV bioelectrography has begun more than 2 centuries ago. So the first name that we need to remember is George Lichtenberg from Germany. In 1777, he was making an experiment with the metal rod that was covered with the glass. And just when he was connecting the wire to this metal rod with his hand, touched it with the hand, he has noticed that there was some kind of emission glow around his hand when he was touching the glass surface. So, well, this effect of fluorescence or glow he has registered, and then he made different types of experiments, not with hand, but with different type of conductive objects, showing that in the high intensity electromagnetic field, the glow appears of animate or inanimate, living or non-living objects. They should be simply conductive. So these first pictures are known as Lichtenberg figures. So time passed by, and next name, very popular one century later, at the end of 19th century, Nikola Tesla was making experiments with electricity, and well, you know that he was the one who has made the alternative current possible. So this alternative current or alternating current has made it possible to make not only high intensity electromagnetic field, but also high frequency electromagnetic field. So while experimenting with these high intensity and high frequency electromagnetic fields, Nikola Tesla has shown that if a person stands near in such an environmental conditions with such a high electromagnetic field, the glow surrounds whole body. So, well, at those times, well, people were not able to understand and describe the nature of this glow. So there were many esoteric interpretations of this glow, so like some kind of aura or biofield or whatsoever. So, in fact, not many people were eager to repeat experiments by Nikola Tesla. Well, you probably know that during this kind of flow, lots of ozone is being accumulated in the air, and it's not so healthy to breathe such saturated with ozone air. So not many people were eager to repeat it, but at least Nikola Tesla has shown that whole body can emit this kind of flow, and also different types of conductive objects. The most interesting for researchers and investigators. were studies of the glow of living objects, of course, human beings and different plants, etc. So, next century, well, at the edge of the next century, Yakov Navpatyev of Russia has also made experiments with high voltage generator, and he didn't simply watch this luminescence or this glow that George Lichtenberg and Nikola Tesla has seen, but he has learned how to capture this luminescence, this glow, on a photographic plate. So as long as it was already some kind of image, a photo, so the term electrography has appeared. So it means that you can not only watch this, but also you can record the glow and then analyze it. So several years later, in Brazil, Father Lanto de Moroa has created an electrographic camera. Well, it was pretty huge and pretty big equipment, and it was really complex and of course dangerous, because playing with high voltage and high intensity fields, high frequency fields, well, it's not so safe, specifically if you don't know the limits, conditions that are good for living beings, like people around you. So, and the complexity and the fact that it's dangerous, well, prevented the method from becoming worldwide spread, but at least it was the device created for this kind of electrode. So, several decades later, in 1933, the family of Simeon and Valentina Kirlian in Russia, they have also registered, noticed the fluorescence of fingers while they were working with high-frequency equipment in hospital. So, as long as the electrotherapy was pretty popular in those years, and this kind of therapy was prescribed to different patients in the clinics and hospitals. So it's just an accident that they have seen it, and they were curious. What is it? This kind of glow around the fingers. So, of course, they started doing their own experiments and their own research, and they were so really excited about this effect. So they spent the rest of their lives doing these kind of experiments with high frequency photography. So they have published lots of papers. They have made lots of these kind of beautiful Kirlian photos. And just because of their enormous impact into the development of this technology, now, even nowadays, this effect is known as Kirlian effect. And the photography is more commonly named as Kirlian photography. So, what has happened next is that Professor Newton Milhomens in Brazil has built his first Kirlian camera that was photographing the glow of fingers on the photographic film. So even though he has based his device on the Soviet electronics team, doesn't matter. Well, he was one of the first ones to make a device that has become pretty popular and widespread. So even now in 21st century, devices by Newton Milhomens are still being produced and being sold in South America, and you can even buy them in other countries. So in 70s and 80s of the 20th century, worldwide, as long as the electronic equipment and all the components become much more available to just engineers, electronics engineers, so they were able to buy them in the shop and then construct their own foil and their own Kirlian camera themselves. So there were lots of researchers and enthusiasts who were making their own Kirlian devices at their home or in their garage. So, and making those interesting, beautiful photos of the globe around different objects, like you see on the screen, leaves and hands, etc., etc. So, but it was more like a game. It was more just for fun and just for curiosity, you know. No special information could be taken from this. Well, they are beautiful, right? It is like that. Not many people were really understanding what kind of mode it is and what to do with it. So, beautiful pictures. That's it. And then Peter Mandel from Germany, who have been playing with this and making lots of research himself with the photos of fingers and toes, he has devised his own equipment. So it's still being constructed nowadays. And I know that there are still some users in Europe, first of all, who are using Peter Mandel's devices, even though they're using just photographic plates, photographic film, but still people are doing it. It's not digitized, it's just manually made. But his good idea was that he has proposed to apply acupuncture point concept to the pictures of the glow of hands, of fingers and toes. So he has overlaid the acupuncture point concept taken from Suzhou, South Korean system, onto the images, and beginning from that moment, he has tried to do some interpretation according to this acupuncture point. So he was relating different parts of the images that he was obtaining with this acupuncture point, and then making the interpretation of the energy state of the person. So, and well, the first diagnostic table has appeared. Well, diagnostic meaning that the pictures of each finger and each toe were divided into sectors, and each sector was connected with some specific organ or system in the body according to the acupuncture concept of Suzhou. Well, only 3 years later, in Brazil, the device by Newton Milholtz has been approved as a Brazilian official standard filament. So, and lots of researchers were using it and in their practices too, and also trying to make some interpretation of the data. But you know, it was still based on manual reproduction of the images. So, end of 20th century, beginning of the computerization and digitalization of everything in our lives. The computers were available for general public, and in 1995-96, a group of scientists that were led by Konstantin Korotkov in St. Petersburg, Russia, they have made a huge step forward in Kirlianography. So instead of doing everything manually, photographing it on a photographic film plate, they have created a digital device that was computerized. So the photograph of the emission of this glow was captured by the CCD matrix, coupled charge device, the video camera, in other words. And this digital image was processed by the computer. So the software has appeared that was able to process the digital Kirlian images. And nowadays, it's Professor Korotkov, a doctor in technical sciences. He has proposed a new name for this method, not Kirlianography, but gas discharge visualization. So because the device was visualizing, photographing the gas discharge or air discharge. So you know that science is based on statistics. And of course, without statistics, without reproducibility, you cannot study anything properly. So thanks to the appearance of this equipment, GDV camera, well, some models one of the first models you can see on the screen right now. Researchers and therapists were able to capture several times the glow, or capture fingers several times in a row, and see reproducibility of the data. It has allowed and made it possible to do the calibration of the device, so to have some kind of reproducibility and to compare the results between them, between each other, and to develop some kind of norms. So, and of course, this has become super popular worldwide, even though it was very expensive equipment. So one device with software could cost 10 or 15 or something, even more $1,000, euro. Still, people were so interested in studying this unknown phenomena about this glow around the human fingers, and people were still thinking, curious, that it is some kind of aura that these devices able to capture. So people started doing scientific research. The software has applied the Peter Mandel table of intersection of the sectors on every finger, and henceforth we were doing some kind of, the software was helping to do some interpretation of every sector and finger, and then making some kind of correlation studies to compare the data from the GDV camera with different other methods of studying the human state. So it was very good, but still Dr. Korotkov was not satisfied enough, because not many people were able to obtain this device. Because it was super expensive, it was constructed in St. Petersburg one by one, so very expensive, and his dream was to create a device that will be affordable for every family. So a big step forward was made in 2014 when MyWell device has appeared, that you can see on the screen. And the software, as long as it is constantly being developed, it was moved to a server. So every user of the MyWell device has own account where all the database is saved, and the only thing people need to do is to have the device, have the subscription to the software, and they can do their own research with lots of parameters that we will discuss later on during this lecture. So the price of this device several times less than previous GDV devices constructed by Dr. Korotkov, companies that has created. So, and this has given a big boost to the development of the GDV technology and nanotechnology. So nowadays, several thousands of users are implementing this technology in IOL device in their practice. And we will discuss in more details what it's all about, what exactly we are capturing, why so many people are interested in that, and also just because it's not an easy effect from the physical point of view to understand, still many people are doubting, is it really measuring what we're saying? Is it really aura that we are measuring, or it's something else? I will clear all the doubts and answer all the questions about the physics of this process later on. So let's move forward. The physical principles of GDV, gas discharge visualization. Well, if you consider the history that we have just discussed, you will understand that there were a lot of confusions around these topics. People were not really understanding what actually they are photographing and what Kirlian photography is about. So, in the beginning, end of 80s, then 19th century, when there was no proper quantum physics understanding, of course they were not able to understand what's going on there. In 20th century, with the development of quantum physics and understanding the processes that are going on those atom molecular level, people were able to understand better. But still, even now in 21st century, lots of people, when they're seeing the Kirlian photograph, say, "Oh, please photograph my aura." But aura has no strict scientific definition. What is it? There's no such term that will describe what kind of it. Yes, this is glow, but what kind of glow? And just because of this lack of knowledge, and even nowadays, not many people really understand quantum physics in order to understand what's going on in Kirlian effect. So they prefer to think that this is some kind of esoteric stuff that is being measured by G. It's not true. And I will try my best to explain it in layman terms, in a pretty simple way, the physics of this technology. So there are two names of this technology. The most widely used, widespread, is gas discharge visualization, or simply GDV. There is another name, electrophotonic imaging. It's also being used in some literature and some publications. So now we need to learn the definition and the essence of these technologies in this definition. I know that it will be a little bit complicated for you to understand it from the first try. That's not a problem. I will explain on the words used in this definition later on. So, GDV or EPI is an analysis based on captured photographing the photonic emission stimulated by the flow of electrons that is created by a high voltage, high intensity electromagnetic impulse and also high frequency. So the essence of this definition is in word stimulated. So it means that this kind of photonic emission, this glow, is not something that we constantly walk with like people hold aura. No, this emission that we get is stimulated. It means we are extracting it. So how this process going on. Step by step, let's discuss. So, when the high voltage is being applied and there is a big difference in electrical potentials between the object, like your hand or metal cylinder that is used with the 5-volt devices, the electrons get attracted by this high voltage, high electrical potential on underneath the glass electrode, in which person the finger or the metal cylinder. And because of this difference in potentials, the electrons are flying away from the surface and the electronic flow is being created. Then these electrons collide with the air gas molecules, excited, and the air molecules emit light. Our devices, 5-volt devices, and all other equivalent GDV devices are photographing this light. Let's try to talk about each step in more details. So this is the principal scheme of GDV device. So you can see here the object. Well, in this case it is finger, but it can be any other conductive object, metal cylinder, calibrator too. So there is a glass electrode, it's transparent dielectric plate, but on the bottom surface of the dielectric plate, you can see here, it's the black line, underneath it is the transparent electrode. So there's a transparent conductive layer underneath the glass, to which the high voltage impulses are being sent by the electromagnetic impulse generator that is inside the GDV device. The glow that is being created in the air is being photographed by the video camera and then transferred as a digital image to the computer. So the first step, the first effect that we need to talk about is called field electron emission, also known as simply field emission or electron field emission, etc. So this process happens when there is a big, strong electric field applied to some conductive object. Just because of this strong electric field, it attracts the electrons from the material, from this conductive object. And it doesn't matter if it's your finger or it's a piece of metal. They're both conductive. That means in both cases, electrons can be extracted. So electrons are attracted by this strong, high-intensity electromagnetic field, and they fly out to the air. What happens next? These electrons, just because they're flying very fast, they collide with the air molecules. And as you can see on these two schemes, after this collision, the electron continues its flight, but it takes out one electron from the molecule and one proton from molecule that fly further away. Then they strike next molecule, again creating more free electrons in the air and more positively charged ions in the air. And as you can see on the second scheme, this same process is going on in the opposite direction, where the positively charged ions are flying towards the negatively charged electrode. So just because of the flow in the opposite directions, the negatively charged ions and positively charged ions, like electrons and protons, the electric current appears in the air, so-called electronic avalanche. So that is also can be seen as coronal discharges because just because of few electrons appearing in the air, they multiply very fast with very high speed and create lots of free electrons in the air. So this process of creation of electronic avalanche is also connected with the next process. So this flow of free electrons in the air, as long as it is not simply vacuum, it is air in which we are making GDV images. The air molecules absorb some of the energy that electrons transfer to them, and they go to the excited energy state. So they increase their energy state. And just because of this increase in energy and due to the laws of the quantum physics, it's not a normal state for multiplier. And it cannot stay at this energy level for a long time. So after some time, it relaxes back to the ground state, initial state of energy, and the excess of energy is emitted in the form of light. So exactly this light we can see on the images in GDV. So that's why you can hear and you can see this kind of glow, and you can hear sound during the gas discharge. Sound is just because this electronic avalanche is propagating through the air with very high speed, and we hear these vibrations, the sound, striking sound. And also we see this beautiful light emission. So this light emission is not of the material itself, it's more of the air. And we are photographing this light emission. And we get these beautiful photos. You can see that the colors of the light are light blue, blue, violet, but the biggest part of this coronal discharge is in ultraviolet spectrum. So it means we cannot see this part by our own eyes. We need to use ultraviolet video cameras in order to register this ultraviolet emission. But it's too expensive to integrate such with ultraviolet sensitive cameras into GDV equipment. That's why we are photographing only visible part of the spectrum. So only that part that you can be seen by your eyes is photographed by well GDV device and other GDV devices. It's in the same spectrum that you see on this picture. Light blue, blue, violet, and the high intensity is seen by us as just white color. As long as we are not applying so much of electricity, and I mean the voltage is not as big as it's being used for different Tesla coils, like devices. In GDV devices, the level of voltage, for example in Firewall, is used somewhere between 3000 volts to 5000 volts. In average, normal device will work 3500 volts. So 3 kilovolts is not as much as being usually used in Tesla devices. In Tesla devices, it's 10,000, 20,000 volts. So, and you can see that because the intensity and the power that we're using is not so big, you will not see bright light, white colors here. You will see that it's mostly blue, slightly violet, and again, the biggest part of the emission is in ultraviolet part of the spectrum that we cannot see with our eyes and is not registered by the equipment. Well, now that we know the physics behind this, we understand that we are photographing not some kind of aura around our body, and we are photographing the corona discharge. And corona discharge is created, and this glow is created by the air that is created by the electronic flow from the material, from the object that is inside. And again, it doesn't matter if it's your finger, it's also conductive, or if it's some kind of metal cylinder, or any other material that you want to study. So, the figures that you see inside these beautiful pictures in Biowell software has nothing to do with work. This is just beautiful computerized redistribution taken from 10 scanned fingers. Figure of the body inside these pictures are just beautiful representation. It doesn't mean that this emission is coming from your legs or from your feet or from your arms, etc. No, it has nothing to do with legs, etc. So we will talk about these sectors, and I will show in the software how it really looks like, how this image is made. So the colors that you see here are also artificial colors. So this coloring is made by the software. It's not the real colors of the emission of the glow between the photograph. So the image with which the Biowell other GDV software is working is actually grayscale. So it works with black and white. There are no other colors there. So absolutely black pixel is 0 intensity. Absolutely white pixel is 255 intensity in relative units. That's it. No colors there. Coloring is made in the software, and I will show you later how it is being done. So let's talk about the human fingers. What is really special about capturing the human fingers? And what's the difference between capturing the finger and capturing some inanimate conductive object? So we have a digital image, like you see on this screen in a grayscale mode. Each digital image has pixels. In case of the Biowell, the size of the image is 370 on 285 pixels. Fixed. It's always like that. It's always 370 on 285. So there, as long as these are pixels, every pixel has its intensity. That you can see, it's measured in relative units, where black is 0, white is 255. So there's like 256 grades. Area is just number of pixels. So if you take the calculator and calculate 370 times 285, you will get 105,450 pixels. So this is the standard number of pixels in the software, in the images that you get. But of course, you are not interested in all these background black pixels, even gray pixels. You're interested in only those pixels that are connected with the glow of the finger or any other object that you are studying. So in our software, we have the area parameter. And area parameter is taking into consideration only those pixels that are not black and that are connected with the glow from the object under study. So you see that there are two main parameters: area, so number of the pixels in the image, meaning only the glow pixel, and intensity of these pixels. And of course, if you multiply them each other, the intensity of the area, you can get a third parameter that is widely used in Biwell software, that is called energy. Of course, to transform these relative units to joules energy, we need to use some specific correction coefficient that is transferring from the joules of the absorbed light to these relative units of intensity, so that we know that if the pixel is 200 relative units, it means this amount of joules of absorbed light. So of course, as long as this light is in quantums, in photons, this photonic emission, as long as we know approximately the wavelength, and it's around 300 nanometers, so violet part of the spectrum. So we can more or less understand and make a calculation of each pixel and transfer these relative units of the digital format into joules of the absorbed light. So in software, we use the joules parameter in many subprograms. But remember, these joules are the joules of the absorbed light. It's not the joules of the person being studied. It's not the joules or energy of the object being studied. No, this is energy of the absorbed by the video camera system matters light. Let's continue and go to the Biwell software in order to look in real time how the processing of the digital image, GTV image, is being made inside the software. You can see on the screen the standard representation of the captured images in Biwell software. So you see these colored images in front of you. Whilst it's not the raw image, it's not the raw data, it's already processed data. On these images, you will see the sectors and the blue, red, violet, orange colors. But the actual initial image looks like this. And as you can see, there is no gray pixels on the background. So the background is absolutely black. This is specifically made by our software by clearing the noise pixels that are not needed for our processing. So only the pixels that are connected with the actual finger are being left on the image. Everything else stays absolutely black. So the colors that you see in the software that looks like this are made by the software based on the spectrum of the image. So if you look at the spectrum of this picture, you will see this kind of graph. So from 0 to 255, it's intensity on the x-axis, and from 0 to unlimited number, actually, the count, the pixel count, number of pixels of this specific intensity. So, for example, we can point on any intensity, and on the right side of the screen, we will see the number of pixels of such intensity. So, for example, in this case, there is intensity 61, and there are 93 pixels of this intensity on the image that we're looking at. This image and this spectrum is innate for Pi-Well 1,